Okay, we're going to talk about cube roots now. So, what even is one? So, obviously, here's a cube, right? Cubes are three-dimensional, so we have length, width, and a height, right? So if you were to find a volume of a cube, for example, you're just multiplying those three numbers together. So that's why we call cube roots, right? Because it's all kind of based off of a cube. So if you take a look at number 1 right here, 4 cubed is written as 4 with an exponent of 3, but it really means to do what? Doesn't it just mean 4 times 4 times 4? Right? And 4 times 4 times 4 just so happens to be 64. So, just like we had perfect squares, we're going to have perfect cubes. Okay? So, the second one, 5 to the third, really just means 5 times 5 times 5, of course. And if you multiply those three together, you get 125. Okay? So, these are numbers that we would refer to as perfect cubes. Okay? If you jump down to the bottom here, I sort of have a list of the first bunch of them. So if you take 1 and cube it, you just get 1. So 1's a perfect cube. 2 cubed is now 8. 3 cubed, 27, and so on. So we had our list of perfect squares that we had been dealing with before. These are now your perfect cubes. So these are numbers you kind of want to get familiar with, because when you see one, you want it, just like when I see like the number 81, I know 81's a perfect square. When I see 16, I know it's a perfect square. So now you kind of want to familiarize yourself with these numbers that are perfect cubes. Okay? So, do you need to memorize this list? No, you don't have to memorize it, but I think it's helpful to have it in front of me. So if I'm taking a test or a quiz that's dealing with perfect cubes, I might make this list for myself. So, and again, I'm not memorizing it. I'm just going to ask myself, what's 1 cubed? What's 2 cubed? What's 3 cubed? What's 4 cubed? So I might just make this list, put it somewhere on my paper so I have it in front of me. Does that make sense so far? Okay, so let's rewind a little bit back up here. The cube root symbol. So I mentioned a little bit to you about this yesterday. So we're used to the square root symbol that just looks like that. And then I told you that there really is a teeny tiny little number here that we don't usually write if it's a square root. But if it's a different kind of root, a cube root or a fourth root or a fifth root, we need some way to designate that that's what I'm doing instead of a square root. So if you look right here, that's exactly what it is. See that teeny tiny 3? Okay, so that number there is called the index. So that symbol now means to take a cube root instead of a square root. So this with no number written there is a square root. And this with the 3 is obviously the cube root. Okay, and then I have a little example right here. So if you saw that symbol, right, that little 3 with the root over the 27, that means cube root of 27. So you need to ask yourself, okay, what number would I cube to get to 27? What times what times what, where all those things are the same, equals 27. And the answer, of course, is 3. So does that kind of make sense? So what is the cube root of 216? 6, right? If you have the chart right in front of you, it's pretty easy to find. Cube root of 216 would just be 6. What's the cube root of 64? 4, right? Okay, so everything's easy when it's a perfect cube, but will it always just be a perfect cube? Of course not. So let's look at oh, we're just estimating? We're not doing them out? I think I'm going to have you do them out. Huh. Hang on one second. Let me just double check. I don't want to make you do a whole thing that you don't have to do. Estimating, simplifying. Oh, maybe you don't have to. All right, so we won't do that part. Now, do you remember yesterday when we were talking about the square root of, I don't know, 10, and we were trying to estimate it to the nearest tenth? So we started off by asking ourselves, okay, well, between what two numbers would it be? And then I kind of played a little guessing game to get as close as I could. So we're going to try and do the same thing with cube roots. So I guess we'll just do this one at the very bottom of the page, this example here. The cube root of 30. So if I'm trying to estimate that to the nearest tenth, let's say, cube root of 30. Well, between what two numbers would it have to fall? It's got to fall between 3 and 4. Because 30 is in between 27 and 64. So it makes sense that the cube root of 30, even though it's not a nice number, it's not a perfect cube, it's going to be 3 point something. You with me? Okay. So I would probably guess real close to the 3, because 30 is awfully close to 27 and it's not very close to 64. So I might guess 3.1. Hopefully you have access to at least a 4 function calculator, those basic ones that can just add, subtract, multiply, divide. If you don't, then you're just going to have to do it up by hand. So I'll do this one up by hand. But if I wanted to check, so I'm guessing it's going to be 3.1. First, I'd have to do 3.1 times 3.1, and then take that answer and multiply by 3.1 again. So let's see how close we get. 1, 3, 3, 9, 1, 6, 9. So I have 9.61, and now I have to multiply it by a 3.1 again. 1, 6, 9, 3, 8, carry the 1, 27, 28. 1, 9, 17, 9, 2. 1, 2, 3 decimal places. Gosh, that's awfully close. So 3.1 cubed gets me to this number. I bet you 3.2 cubed is going to be way too high. Yeah, 32.768. So if I'm forced to do it by hand, I can. It's just tedious because you have to multiply so much. So tell me between what two numbers the cube root of 400 would land. It's got to be between 7 and 8, right? And then we can whittle it down from there. Where would the cube root of 7 go? In between what two numbers? 1 and 2. So easy enough to kind of guesstimate. All right, so let's take a look at the back. What do I have you doing on the back here? Oh, I kind of work our way through it. All right, I think that's all that I needed to talk to you about with these perfect. I feel like there's got to be more though. So we can basically do the same thing like when you have the square root of 75 and you simplify it. I thought we did that with cubes, but let me just double check. You definitely do it in algebra 2. Yeah, you do. Okay. I'm not crazy. All right, let's try simplifying some of them. I just don't have it on this worksheet. Okay. New page. This notebook is so much fun. Okay, so let's simplify cube roots. Okay, so we're going to start off basically the same way. Just like when I had square roots, I wrote the list of perfect squares on the side. I'm going to write the list of perfect cubes on the side. just because it helps me to have them right in front of me. So I'm just recopying them from the sheet. But you could do them in your head, right? 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. And you can see they get real big real fast. Alright, so I have some perfect cubes here in front of me. Let's say I wanted to simplify the cube root of 80. The steps are exactly the same. I'm going to look in my list for the largest perfect cube, though, that divides into 80. So in this case, the biggest perfect cube that divides into 80 is 8. So I'm going to split this up into the cube root of 8 times the cube root of 10. And here's something that I'm going to warn you against. Sometimes we get a little lazy and we don't write these 3's. You have to. It is so important because if you don't write the 3's, now you're talking square root, which is totally different than cube root. So we have to write them, okay? But I know what the cube root of 8 is. It's just 2. So this just becomes 2, and then the cube root of 10 just stays. So my steps are the same. I just have to be thinking cubes instead of squares. Let's try another one. What if I asked you for the cube root of I want to pick good numbers. 256. So I'm looking in this list. Obviously, these numbers are too big. 125 can't go in because that would have to end in a 5. Maybe 64. So let's see. 256 divided by 64. Well, what do you know? Goes in 4 times. So I would split this one up into the cube root of, what did I say, 64? Times the cube root of 4. And what is the cube root of 64? 4, right? It's just 4. And then the cube root of 4 you can't simplify. That's done. Does that make sense? I know it feels weird to leave that 4 under there because you're so used to square root of 4 being 2. But we're not in squares anymore. We're talking cubes. Okay, you tried this one. How about the cube root of 5,000? Got it? What is the largest perfect cube that goes into 5,000? 1,000 times the cube root of 5, right? And the cube root of 1,000 is just 10. So there is your answer. 10 cube root 5. Okay? Is this all right? All right. So tomorrow we're going to add variables into this. And things get real weird then. Okay, so I think we'll stop here.